Okay, so in section 8.2, you were introduced to series and different kinds of series. You've seen harmonic series and geometric series and telescoping series, and you've learned about the test for divergence and good information. Well, it doesn't end there, class, because there's many different kinds of very important series that we need to understand and determine if the series converge or diverge. So section 8.3 deals with what are called integral and comparison tests. We're going to focus on comparison tests today, and let me give you a moment to copy the two examples down in your notes. Okay, so how many of you noticed that these series appear to be perhaps a little more interesting, a little more complicated, so to speak? Like the first series. The first series, one moment. Hold on, hold on. Okay, so that series there, okay, the terms of the series, we could expand that series out and write out the terms of the series. Now, what we're going to do is we're going to make a comparison. We're going to make a comparison for that series. And there's a special series, in section 8.3 known as, hold on, I got to get the font to, can never get it where I want it. All right. There's a special series called a P series. P series is defined by the summation where n equals 1 to infinity. Hold on, let me give myself a little more room here. I don't like being I like having room. I like having a little space. A P series. Okay, P series is a series where n goes from 1 to infinity of 1 divided by n to the pth power. That's called a P series. And that series converges. They prove it in section 8.3. The series converges if that power P is greater than 1. Okay, so a P series P series converges when the power P is greater than 1. So for instance, if you had a series like this, if you had this series, okay, the series 1 over n squared. Okay, that's 1 plus what? 1/4. That's when n is 2 plus 1/9 plus 1/16 and so forth. Okay, that series converges because what's P equal to? What's P equal to in this series? Good, Jonathan. Good, Clay. P equals 2. All right, just trying to make sure the notes are nice and neat. That's right. It converges because here, you know, I guess I could say I can do a little bit more here. Just trying to make sure everything looks good. Why? Because it's a P series with P equals 2, which is greater than 1. So this result is going to be very handy, this result, and it's something you'll need to learn. Okay, for exam 4, you'll need to know this fact. What we're going to do is we're going to take this rather complicated series and we're going to try to compare it to an appropriate P series. So let's go to the next page and I'll show you how we do this. Okay, so this is a term of the series. So remember the series that I'm interested in for part A is this series. Okay. And of course, the 5 over 2n squared plus 4n plus 3, that's my term of the series. So I'm going to look at that term of the series. I'm going to look at that term of the series, and which is complicated, but I can say, hey, that term is less than 5 over 2n squared. Certainly 5 divided by 2n squared plus 4n plus 3 would be less than 5 over 2n squared. Now, why do I want to make that kind of comparison? It's because I know something about the series. Okay, I know something about the series where the terms are 5 over 2n squared. So this is, you know, a sub n is 5 over 2n squared plus 4n plus 3, and 5 over 2n squared is b sub n. So it turns out that the series where n equals 1 to infinity of 5 over 2n squared, we can factor out the 5 halves. That's going to equal 5 halves times the series 1 over n squared. But that series has to converge because it's a multiple of a P series, a convergent P series. Let me give you a moment to catch up here. I think I want to make sure I'm not going too fast. Okay, so I mean we've established then that our series, okay, our series here, this series here, that series converges. It converges. Okay, so let me show you again really what we're doing here. Let me go to the whiteboard. And okay, and we won't have time to do part B. We can do that next on Monday, but we can finish up the A part here. Hold on, where's my whiteboard? All right, so okay, so this is our series. And I'm saying that series, and notice too, all the terms are positive. All the terms of the series are positive. So if the terms of the series are not all positive, if you have positive and negative terms of the series, then you can't use the comparison test like I'm doing here. But you know that the series we're interested in is less than the series 5 over 2n squared, because the series 5 over 2n squared, that series, hold on, that series is just 5 times the series 5 halves times the series 1 over n squared. And this converges. That series converges because it's a p series. With p equals 2, which is greater than 1. So the fact that the bigger series converges, so the finite, it has a finite sum, that means then that the smaller series here also has to converge, right? I mean, if the bigger series converges to a sum, finite sum, the smaller series has to converge as well, right? And that's called the comparison test. That's the comparison test. Okay, that's called the comparison test. So if you have two series, each with all positive terms, if the larger series converges, the smaller series has to converge as well. And let me just show this in the ebook real quick. This is all on the recording. Hold on here. One moment. For the comparison test, this is section 8.3, there are two parts to it, and we use the first part. If you have a series that's convergent, and then you have another series, you have two series, one with summation with the a n terms, one with summation b n terms. all positive terms. If the larger series is convergent, then the smaller series is convergent. Now, it also follows, by the way, in part B, that if your smaller series, no, hold on. Yeah, if it turns out that the smaller series diverges, then the larger series has to diverge. You see, so that's how the comparison test works. Yeah, if the smaller series diverges, then the bigger series diverges. That's part B. Part A is if the larger series converges, then the smaller series converges. Yeah, then the smaller series converges. Are there any questions on that? That's the comparison test. And I think we'll, our time, we're done here. So, but how many are so far? I think some of you are liking this, and that's good. Are there any questions before I stop the recording? Okay, comparison test is section 8.3. That's where this is from. Okay.